Hello everyone, my name is Reynold. Today I'm talking about the cell response in a marine mollusk and its factors like water temperature or pH. Okay, first, you may ask what subtle response is. So you can see this picture, like mammals. They just can run away to prevent them from being eaten by the predator. So this is the kind of prey defenses, and also is a kind of subtle responses. And about the bivalves, they cannot run away because they don't have feet like mammals, so they just close their shell and to prevent them from being eaten by the predator. So this is the bivalve subtle responses. Okay, so let's go back to our topic. Why choose the subtle response to do the research? First, about the invertebrates, only a few studies are about the prey defenses. Most of the studies is about variation in the prey and predators dynamics. And next one is predator and prey interaction is very important to the animal ecology. So because this is the major driving force to the ecology and the evolution of the biological systems. Okay, the next point was we want to see the global warming whether make a big impact on this species, even our ecosystems. Okay, let's talk about our goal of this study. We want to assess aspects relate to the behavioral ecology of bivalves, subtle responses, and we want to test the combined effect of pH and temperature on the bivalve subtle responses. Okay, let's talk about our prediction. First, we think the subtle response will be repeatable. I mean, we can do the same experiment with the same setup. So, and we can get the familiar result. And next is the time to open will decrease over time due to fatigue or habituation. Fatigue and habituation. It means someone is used to something or somebody. Okay, next one is larger animals will have the shorter subtle response. And because large animal, we think the large animal will have less chance to being eaten by the predators. Okay, next one is the higher temperature will reduce the time to open. Because higher temperature will increase the metabolic rate. So the animal need to more oxygen. So they need to open up their shells to breathe. Okay, next point is low pH would affect the subtle response. And because many reports say that ocean acidification will make a big impact on the animal behaviors, so we also think low pH would affect the subtle response. Actually, the last 2 points were out of our prediction. I will give you some evidence to during this talk. Okay, let's talk about the method. Okay, our experiment is designed in 2 pH levels and 2 temperatures. We want to simulate the different conditions in the ocean. And we cross in a fully factorial manner like this. So we can test each factor by these 4 different treatments. And this picture shows where we do the experiment. And this picture you can see the muscles in the chamber. Okay, and let's talk about how we do the ethics. First, we use the stick to touch the mental tissue until it closes. There is the mental tissue. And next, we will use the stopwatch and record the time that we opened. Okay, and this process was repeated over 4 consecutive trials. Okay, let's talk about the result and the discussion. First, I want to talk about the size. You can see this figure. The y-axis is the time to open, and the x-axis is the size collapse. You can see the gray one is the small, and the orange one is the large. You can see the small muscles, the time to open was longer than the large ones. So we think the smaller muscles are more vulnerable to predation than the large ones. Yeah, I mean the predator prefer to eat the small one muscles. And so time to open appears to be at least partly dominated by the relative vulnerability. Okay, let's go on about temperature. The y-axis also the time to open, and x-axis is temperature. The blue one is low temperature, and the pink one is high temperature. And so we can see the higher temperature treatment remains longer than the low temperature one. So at first, we predict that high temperature increase the metabolic rate, but so we think the time to open will decrease. But on the contrary to our prediction, elevated temperature will increase the time to open. So there is some possible reason. Elevated temperatures can also increase the endothermic predator activity, like crocodile or fish. So that means the muscles have more chance to be eaten by those predators. And another point is increased metabolic rate means the muscles will emit more carbon dioxide, which is the chemical signal can be detected by the predator, so this will also increase the detectability. Okay, let's talk about the effects of pH on the time to open. You can see the y-axis is the time to open, and the x-axis is 4 different treatments about our experiment. So according to this figure, we can conclude the pH seems no significant effect on time to open. And although the many reports that ocean acidification will make the impact on the animal behaviors, but in contrast, we observe there is no effect of low pH on the time to open. So we think the impact of acidification seems to be overestimated. Okay, let's talk about repeatability. The most important thing of this figure is the R value there. We estimate the R value was estimated to be 0.56, and we based on this statistic method. When R value larger than 0.37, we can denoting that has significant repeatability. So, according to the result, we observe a high degree of repeatability in time to open. So this can provide us a useful model for behavioral ecology. Okay. So this is the tired muscles or evidence of habituation. Across the 4 consecutive trials, time to open linearly decreased as the trials progress, like this, the black dot. So we suggest the habituation is more likely. Because we think the animal has the ability to strike a balance between a risk of being consumed and the energy intake. So we think the habituation is more likely. Okay, this point is about population and the community level effect. We know that high temperature and high predator activity will reduce the food intake of bivalves. So the ecosystem benefit provided by those also will be influenced. Just like they can cycle in the nutrients and clean the water. So it is possible that ocean warming will influence benthic system worldwide. Okay, this is about the conclusion. About the conclusion, we can see our prediction and check some points. First, the startle responses is repeatable, yes, and the time to open will decrease over time. We think it's due to captivation more likely, and large animals would have a shorter startle response, yes, and this is a higher temperature actually will increase the time to open, and lower pH have no effect on the startle response. So about the future prospects, we wish the future would have the studies that can quantify the effects of warming on the ecosystem services, so we can have enough information to do such like those studies. Thanks for listening.
First, I think Reynold has a great stage performance, and he add many new slides like mussel don't have feet, so they need to closer share to startle from the predators. So I think it's very good.
Your talk to put a lot of images for audience to look, but your slide had many difficult words. I think can change to easy words for audience to look at your slide.